Welcome to Shipping Sales Apps with Docker Containers. My name's Connor. I wanted to give a brief outline of what we'll be discussing today so that you know what to expect from this presentation. We're mainly going to be operating at a high-level overview of how we can use Sails.js in Docker, but we'll look at some very simple examples of a Sails.js app using Docker. So here's what we'll cover today. Who am I? How I discovered Sails.js, a quick intro to Docker, what problems does Docker solve for Sails developers, a simple Sails app with Docker, and Sails deployment pipeline at 30,000 feet. So who am I? My name's Connor. I live in Toronto, Ontario, Canada, and I'm a developer. Here's a photo of me running my first 10K race alongside the wonderful drawing of me for this wonderful Sails comp. I work for a company called ASICS. You might be familiar with them as they may make your shoes, or you may have seen athletes wear the shoes at the Olympics. Specifically, I work on the ASICS running apps team, which is the group responsible for the RaceRoster and Runkeeper platforms. If you're not familiar with these platforms, RaceRoster helps event managers organize and facilitate race events like running or cycling, provides functionality to help organizers with problems such as event registration, race timing, fundraising, volunteering, and more. Runkeeper is a GPS fitness tracking app for iOS and Android. It helps both new and experienced runners achieve their running goals and engage with their running community. I also do work with a company called Juniper CDS, which is a healthcare startup built around Node.js. They provide point-of-care applications to help healthcare practitioners provide optimal, person-centric care to patients. It was here with my work with Juniper CDS that I discovered Sails.js. So how did I stumble upon this wonderful framework? For many years now, I've worked as a PHP developer and was able to become very familiar with a popular PHP framework called Laravel. What I like about Laravel was that it worked out of the box, was easy to configure, and had ample support from both the developers and the community. If you're curious to learn a bit more about Laravel, I recommend checking out the Laravel Origins documentary. With my work with Juniper CDS, one of the requirements was that whatever we built had to be built in Node.js, since the rest of the technology thus far had been built with Node.js. For a startup, we wanted to reduce as many blockers or as barriers as possible, and building a whole platform in a different language would likely be a barrier for the other developers in the future if they ever needed to work on what I was going to be building. So I began my investigation into Node.js frameworks. I knew my general requirements for what I was building and knew that I ideally wanted something that would allow me to build apps in a similar way that you can with Laravel. I looked at many different Node.js frameworks and finally chose Sails.js for one big reason. Sails just works. To get a Sails app working, it takes no extra configuration. I was up and running in less than a minute while following the initial tutorial. Many other frameworks required lots of configuration before you could even start your app, or their documentation wouldn't specify certain requirements, so I was left fumbling trying to figure out how to get a simple Hello World app started. The fact that it was easy to get started with Sails.js was an immediate good sign for me. Since then, I've been fortunate enough to join the Sails community. I've built my own package to help with .env file loading in Sails apps, and now I get to be part of this great conference, and I appreciate all the work that the Sails community does, and I feel very lucky to be a part of it. Now, on to what we're all here for. To begin, I wanted to give a brief overview of Docker so that anyone joining this presentation can understand what's going on, at least at a basic level, even if you've never used or heard of Docker before. My overview is heavily influenced by Nigel Poulton's book, Docker Deep Dive, so if you're interested in learning more about Docker, then I highly recommend you check out his book. So before we get into how Docker works, we should go back in time and understand what problem Docker was trying to solve. So the bad old days. Most applications run on servers. In the past, we could only run one application per server. We just didn't have the ability to run multiple applications safely and securely on one server. What ended up happening was that every time the business needed a new application, the IT department would buy a new server, not knowing what the actual performance requirements for that server should be, and this often led to buying servers that were the biggest and baddest ones they could buy. This would end up costing the business a lot of money. The other problem was that these overpowered servers were operating as low as 5 to 10% of their potential capacity. So along comes VMware. With VMware Inc., we got virtual machines, and all of a sudden we could safely and securely run multiple applications on a single server. But virtual machines have their flaws. Every VM requires its own dedicated operating system, and since every OS consumes CPU, RAM, and other resources that could be otherwise used to power more applications, every OS needs patching and monitoring, and in some cases, such as Windows, requires a license. VMs are also slow to boot. Next coming up is containers. Containers are roughly analogous to VMs, but the major difference is that containers don't require their own OS. Instead, all containers on a single host share the host's OS, which frees up a huge amount of system resources such as CPU, RAM, and storage. It also reduces potential licensing costs and the overhead of OS patching and other maintenance. Containers are also fast to start and ultra portable, meaning moving container workloads from your laptop to the cloud or to virtual machines or bare metal in your data center is a breeze. So now Docker. Docker is software that runs on Linux and Windows. It can also run on your Mac, but when you run Docker containers on your Mac, it's actually running Linux containers inside of Docker Desktop. So Docker allows you to create and manage and orchestrate containers. When most people talk about Docker, they're referring to the technology that runs the containers. One technology we'll use today is called Docker Compose. Docker Compose is a tool for defining and running multi-container Docker applications. You use a YAML file to configure your application services and just go from there. So what problems does Docker solve for us as Sails.js developers? Docker has many advantages like we've already seen, but here I just wanted to outline a few that may be specific to node development. So simplified maintenance. We all know that managing our packaged JSON file can be a pain, especially when it comes time to updating our dependencies. What amplifies this pain is when we upgrade our node version on our machine for one project, but for another project we actually still need that older node version. We could use something like NVM and switch our node version every time we change projects, or we could use Docker to manage the node version per container. For each image we create, we can specify the node version and just forget. We don't need to worry about which node version is on our host machine. Updating the version is simple and requires no real extra configuration. Portability across machines. When it comes time to share our images or deploy our projects, Docker makes this easy for us. Using technologies like Docker BuildX, we can build our images for multiple platforms. No longer do you need to make one compiled version for one version of an OS and another compiled version for another version. Now we can make a single image that works for both or many operating systems. Rapid application deployment. Because containers include minimal runtime requirements for their application, their reduced size allows them to be deployed extremely quickly. Version control. We can track successive versions of a container, inspect differences, and roll back to previous versions. This means that when a breaking issue is detected on our production environment, we can quickly roll back to the previous version without much overhead. We can also tag a broken version so that we can avoid using it in the future and investigate why the bug occurred on that version. Component reuse. Because containers reuse components from preceding layers, it makes them lighter weight and easy to build when we only make minor changes. So let's look at an example. So here we have our Sails project, and if we look in the Docker directory I have set up, you can see the dev Docker file I created. It's super straightforward. We basically just start from a base node 16 image, update all the system dependencies, set our working directory, and copy the contents of the project into the image working directory. For the production Docker file, the only difference would be that we would be more selective with which files we copy over. Some files we don't necessarily need in a production image, whereas for dev image, it may be beneficial to just throw everything in there. So now we'll look at our docker compose.dev.yaml file. We're using Docker Compose here to manage 3 containers. The first is our primary application container. The second is a worker container that can perform such actions as running tests and static analysis. The benefit of having this as a separate container is that your primary application container can be more purpose-built and therefore doesn't have to worry about handling requests and running unit tests at the same time. The third container is our database container. For our dev configuration, we have a MariaDB database container, but for our production application, we wouldn't have this database container set. Instead, our primary container would interact with a database hosted on something like AWS RDS, for example, or any other cloud database hosting service. For our database container, we can also optionally define a directory that has SQL dumps that can be auto-loaded into the database on container creation, negating the need to go run migrations or manually write SQL queries to add fixture data for our dev environment. We also define the order that containers should be spun up. Here we can see that we specify the creation of the database container before the creation of our primary application container. This is because if we tried to create our primary application container before our database container, we may get a failure message since our application is attempting to connect to a database that does not exist yet. When we look at our production Docker Compose file, we can see it's very simple. It defines the various ports and working directories. One important difference here is that with the dev compose file, we defined a Docker file with various configuration parameters as our image. Here we reference an image hosted on the GitHub container registry. Registry is just a place where Docker images can be hosted. GitHub container registry is just one example. There's also the Docker registry, or AWS also has their own version, and many other companies have hosting for Docker images. Now we'll look at spinning up our local containers. To make things simpler, I created a makefile that handles all the Docker commands. If you've worked with Docker before, then you know how unwieldy these Docker commands can become. What I found useful is to leverage a makefile or a custom script file that allows you to run the various commands more easily. For this demo, we have a two-stage process. The first stage is to create the images. The second stage is to create the containers. I've captured these two stages with two simple commands, make dev build command and make dev up. The terminology is meant to reference the Docker terminology in that we build images and start up or spin up containers. Let's watch it happen. So first I run the make dev build. We can see the images being created very quickly. In our case, there isn't a lot going into these containers, so they get created quite quick. When you run into larger projects, things like Java containers, you can end up with a fairly long build time. Nigel Poulton, who I referenced earlier as the author of Docker Deep Dive, recommends trying to cap your build times at 5 minutes. You can put checks in place with something like GitHub Actions to test build times with each PR, determine if a specific change has pushed the build time beyond a desirable limit, and then make the appropriate changes to bring it back down. The reason for all this is because shorter build times allow us to have a rapid feedback cycle, meaning developers don't have to spend as much time waiting for builds to finish and can spend more time writing code and solving problems. The next command we'll run is make dev up. Docker Compose has a useful output where you can see the name of the service being created and the logs from that container. First we see it start to create our MariaDB container, then partway it quickly finishes creating our node worker container, then goes back to working on our database container. The outputs you see can be very useful when it comes to debugging why a container isn't working or starting up correctly. You can see where in the creation process it fails and work backward from there. Once we finish creating the database containers, it moves on to creating our primary application container. And then once it's done, we can go and see that our Sails app has started. And if we go to localhost 1337, we can see our application up and running there. Now that we've seen an example of spinning up our containers for our Sails.js app, I wanted to take a step further and talk about what it might look like to deploy our Sails app to production. I use the term at 30,000 feet to mean at a very high level. We're not going to get into the nitty gritty. We're just going to talk about what it might look like so that if you have an interest in exploring more after this presentation, you at least have somewhere to start looking. Our basic deployment pipeline has about 5 steps. 1. Commit to the main branch. 2. Run the test suite. 3. Create a release. 4. Build and publish the image. And 5. Deploy the containers to the new environments. A visual representation of this in an AWS specific context would look something like this. It's missing a few steps, but we can imagine they are there. So 1, we write our code and package as a Docker image. What's missing here is just running our test suite, creating the release, and building our image. Creating release isn't always required for certain projects, but for things like APIs, it would be. One technology we can use, for example, to run our test suites and build our image would be something like GitHub Actions. Number 2, Amazon ECR. Here we're publishing our image to Amazon ECR. ECR stands for Elastic Container Registry. Like I said before, this is just AWS's version of a container registry. There's also GitHub Container Registry or the Docker Registry. It's just a place to host your Docker images. What Amazon ECR handles is compressing, encrypting, and controlling access to our images once they're in the registry. It also handles versioning, tagging, and image life cycles. Most registries do some form of this, so whichever registry you choose is pretty much going to be able to handle what you're looking for. And number 3, run our containers. After our images are in the registry, we can deploy those containers to our new environments. In the diagram, they reference ECS and EKS as the AWS services, but those are just the managed services. ECS stands for Elastic Container Service, and EKS stands for Elastic Kubernetes Service. We can also deploy our images to non-managed services such as EC2. From there, we can start up our containers ourselves with something like Docker Compose. We can write a script that handles the deployment and creating those new containers from the new images. Each has its own pros and cons depending on what your needs are. There's a handy diagram I found to help you make your decision. Just throwing it up on screen here now. If you're interested, just pause the video. So in conclusion, I hope you enjoyed learning today a bit about Docker containers and Sails.js. We discussed a bit of the Docker technology. We got to see creating containers in action. We talked about the Sails deployment pipeline at 30,000 feet. All the resources for my presentation will be included in the description of the video, including my website, where you can reach out to me if you have any questions or are interested in doing what we're doing over at ASICS Running Apps or Juniper CDS. Thanks for coming to my presentation, and I hope you have a great rest of SailsConf.